Welcome back to Math with Patrick. It's April 28th, and we have problem number 118 to solve from the Daily Epsilon calendar. All right, so I see that y is equal to some number right here. It's log base 7 of 4. And once I plug in that value of y here and here, raise 4 to some power, I'm supposed to get the number 28. Okay, let's just try to solve it directly. Like, it looks like I could just substitute log base 7 of 4 into here. So log base 7 of 4, that's this y right here. I'm going to add 1, just so I don't think it's like log base 7 of 4 plus 1. I am going to put parentheses around this guy, just to be super clear what I'm doing. And then finally, it's over y again. So log base 7 of 4. This looks kind of gross, honestly. I mean, maybe I could have rewritten this fraction. It's like y plus 1 over y. That is the same thing as 1 plus 1 over y. So like 1 plus 1 over log base 7 of 4. This could be my exponent. I don't really like it though, honestly, because I don't really know what to do with that. Let me try something else actually. So looking at this first equation, y equals log base 7 of 4, I know that I can like rewrite logarithm equations as exponential equations. This is the same thing as saying 7 to the power of y is equal to 4. And maybe I could replace this 4 with a 7 to the power of y. And that's still going to be raised to the power of y plus 1 over y. And the reason I'm doing it this way is because I know that when we have stacked exponents, like some base to the power of x to the power of y, you can just multiply those exponents. And when you end up multiplying y by this fraction, these two y's cancel out. And so this should just be equal to 7 to the power of y plus 1, which is a little bit simpler, right? I don't have any weird nasty fractions to worry about. So I could say that this is equal to that, which is equal to that. Maybe I could plug in the y at this point. I have 7 to the power of log base 7 of 4 plus 1. And yeah, why not? Let's use another log rule here. If I have a base and I have a power that is a sum, then I can split up the sum kind of like this. So this is the same as 7 to the power of log base 7 of 4 times 7 to the power of 1. I'm just splitting up this exponent like that using the log rule on the right. 7 to the power of 1 is fairly easy. That's just a 7. This one's a little bit weirder, but I know that this is just the number 4. This number is whatever number I need to put here as an exponent on 7 to equal 4. So whatever this question mark is the same value as the number in that box. 7 to some exponent could equal 4. I know that exponent is between 0 and 1, just because if I put a 0 here, I get a 1 on this side, and that's too low. And if I put a 1 here, I get a 7 on this side, and that's too big. So this question mark exponent is going to be somewhere between 0 and 1. I'm not really sure what it is, but that number is the magical number that when I raise 7 to some power, I get 4. And whatever that number is, I'm raising 7 to that power. So I essentially am getting the number 4 out of this expression on the left. It's a little weird, but you could just think that these things just cancel each other out, and I'm just left with a 4. 4 times 7 is 28. That's today's date. Cool. Well, we're all done. Maybe there was a way to solve it just by plugging this in here and here, but it felt nice to get this cancellation of y's, and ultimately that's just kind of what made sense to me today. I got 28. Hopefully, if you try to solve this on your own, maybe a different way, you also get 28 too. And either way, I'll plan to see you tomorrow. All right.